So when we have a problem like this, we can take one way ANOVA as well as two ways, because we have two factors here. The first factor are the departments, and then the second factors are the time that the students spend in preparing for the exams. I was about to say we can even enter the data directly in SPSS instead of entering and transferring or copying or importing. Let's just open a new spreadsheet in SPSS and enter the data directly. When I say copy to SPSS, some of us, we end up copying those names, the heading. You go and type biology now. You see some people, the biology, what's the second one? Agric, maths, you see some of them will type it here. It's wrong. I hope you know that. And even the time interval. Some people will type it here. It's also wrong. Because what we need here is just what? The numeric values or the scores. So if you have typed anything like that, just remove it. Because SPSS do not accept any other variable apart from numbers. So what I can do now to help myself is to come here and call this one maths, biology, and agric, right? Yes, agric. All right. So that's the best I can do. If I really want to, time, there's no how I can put time. If I want to put time now, the only thing I can put there is 1, 2, 3, 4, 5. Yeah. Are we listening? That interval, 0 to 9, you can't write it here because it's not numeric numbers. So what we can do is just to come here and do what? 0 to 1, you call it 1, and type 1 here. 10 to 19 is 2, you type 2. Okay? That was why I brought this kind of data. Don't say because you have words. Now you cannot carry out that analysis because of the it brought strange. You see strange there, you cannot analyze. That's what I'm saying, that before that mass, create a column, then put 1, 4, 5. Then you go back to variable view and name it. No, some people have already brought that time here. Some people have brought that time and it's wrong. That's 0 to 9 hours. If you bring it here, it's wrong. Just bring 1, 2, 3 and then go back and name what your 1 stands for. 1 is 0 to 9 hours. So you go and name it in variable view. So you see the reason why I brought this, so that you don't make such mistakes. Let me show you what I'm talking about here. We insert a variable here, call it 1, 2, 4, 5. Okay? Go to view and call it what? Hours. Then you name it. 1 means what? 0 to 9 hours. 2 will be 10 to 19 hours. 3 is 29 to 30 hours. 20 to 29 hours. 4 will now be 30 to 39 hours. 5 is 40 to 49 hours, or we can just say 40 and above. That's, you don't have to bring words. Your Now let's cut. Mm. 1, 2, 3, 4, 5. It's 5, 5. 1, 5 times. So the 1 stands for maths department. Yes, because we have 5 observations or data points there. 2 is for biology. And we have another 5. Maybe we should take unequal sample size, because it's not always that you have equal sample size, so that you can see how to also arrange if it's unequal. Don't worry, the next example, let's take this one first. So we start, copy or cut. Let's copy, paste here. Then copy biology and paste beside 2. And copy agric and paste beside 3. Now you understand what you are doing. All right. So we have to rename variable 8 and 9. So what's the name for the grouping? This variable 8, what's the name? The departments. These are departments, not subjects. It's departments. So we call variable 8 department. Then what do we call variable 9? The scores. Scores. All right. Then we go to values. For department 1 is maths, mathematics. 2 is biology, and 3 is departments are the nominal, scores are the scale, therefore it is targets. We don't have time to test for normality, but I'm sure that 90 is not an outlier, because there is 80. So what of 21? 21 could be an outlier. It's possible. Is it that close? Let's quickly run the normality test for scores. Data is normally distributed. Have you seen it? Our p-value there is 0.918. And we don't have outlier, so we can proceed. All right, so let's take the test now. We start from analyze. From analyze, we go to compare means, and then we stop at one-way analysis of variance. Then you click on one-way analysis of variance. When you do that, you have this dialog box. We have dependent list and factor list. Don't forget that the factor are your categorical variable or your independent variable. So which one is the factor, department? And even from the, don't forget I told you about this symbol. The symbols already indicate that it's nominal, okay? While the other ones shows that they are scale. So we move department to factors. Move department to factors. And then we move scores to dependent list. See post hoc test there. And remember I told us it's not automatic. You take the test first. All right, so click on options. Click on options. Under options, we pick descriptive. Fixed and random effect, we don't need it. That's for maybe all this panel data analysis and all that. That's when we take fixed or random effects. But we need the homogeneity of variance tests. Then we need the means plot. Means plot. It will give us a graphical representation of the mean. So we have picked descriptive, homogeneity of variance test, and means plot. All right, continue and okay. Continue and okay. All right, let's admire the results as usual. We have beautiful looking results. SPSS has one of the most beautiful way of presenting results. So let's know whether we need to take a further test. Do we need to take a further test? Check the p-value first. Do we need to take a further test? Yes or no? Only 2 people are responding. Do we need to take a further test? I'm watching our mouth. Do we need to take a further test? Yes. The answer is yes. Look at the p-value here. Have you seen it? It's less than 0.05. Therefore, we are rejecting, meaning that we have significant difference in the mean score of the 3 departments. So before we go further, let's take that test. Minimize. We go back to analyze, compare means, one-way ANOVA, post hoc. Then we pick LSD because the data is not that large. If you have large data, then you now start comparing, considering the Duncans and Tukey and all that. But for this size of data, LSD we do, okay? Very, very. And I'm looking at the time, that's why. Okay, so where do you want me to start with the explanation now? Oh, with the analysis. Oh, post hoc. All right, all right, all right, all right. Okay, so now let's start. If you have written it before, there's no need. We start from analyze, right? Compare means, and then we go to one-way ANOVA. Click on one-way ANOVA, and you have this dialog box. When you see me rushing like that, I started looking at the time. It's almost time for us to go, that's why. And I want us to take one classwork before we go. I don't want you to dodge the classwork. Because when it's time now, you say it's time. All right, so here we have our dialog box, dependent list. The other one, even though they wrote factor, we know that what we need to send there is the what? Independent list or the independent variable, okay? Don't let SPSS confuse you by using factor. The factor means insert your independent variable there, okay? And our independent variable, which is categorical, is department. Therefore, we move department to factor. And the continuous variable here, or the scaled variable, is score. So you move scores to dependent list. All right. Now we can activate the post hoc test, okay? Because p-value is less than level of significance. We can activate the post hoc test because p-value is less than the level of significance. That is, there is a significant difference. There is a significant difference in the mean score. There is a significant difference in the mean score. Are we okay now? Can I continue? Yeah. All right. So let's click on post hoc. Click on post hoc test. And I said, if your sample is, let's say the units or the size is below 100, the sample or the size of the data is small. Therefore, we can use LSD. But when the size of the data increase above 100, then you consider using, there are three of them you consider using. You can use Duncan, you can use Tukey and Shifi. I'm still on it, I've not left. Okay, I said when your sample size is small, then you consider using Duncan, you can use Tukey and Shifi. I'm still on it, I've not left. Okay, I said when your sample size is small, then you consider using let's say, for example, if the sample size is below 100, so, sorry, not the sample size, the weight, the units, the digits of your scores. Okay? I'm trying to say, you know that sometimes you have 3 digits, which is 100. So if you have 100 and below, not the sample size now, the unit or the digits of your unit is right, the unit of your data. If it's less than 3 units, that's hundreds, then you consider using LSD. But if it is above 3 units, if it's like thousands, okay, then you consider using Duncan, Shifi, and Tukey. I don't know about that Tukey's B, the one that is just Tukey. Yes. All right. No, I saw it. We met the condition. Just that I didn't say it. We met that condition. Yes. Okay, you saw it. Okay. I saw it too. That's why it's not showing. See it. Can you see the condition? The one is talking about the equality of variance test. See the p-value. Can you see it? 0.334. So it's greater than 0.05. So we met that condition. Sorry, I forgot to mention it. You know, the first test we did, I saw it, and I also saw the p-value. Okay? So because we met that condition, you can pick any of the first 14 multiple comparison tests. But supposing this value now is lower than 0.05, then we pick any of those 4. Any of those 4. The names. Tam what? Tam Hen, Dunet, Games Howell. All right. Now let's continue. Let's continue with our. So we pick LSD and continue. Then we go to options. Click on options. Under options, we select descriptive. We have taken this test already, but let's take it again. Homogeneity of variance test and means plot. All right. Can we continue now? So click on continue and OK. Click on continue and OK. All right, the mean score of the students from mathematics department is 44.2. Mean score of students from biology is 80.2, while students from agric has a mean score of 53.6. So from here, we can decide, we can even say that we have difference though we don't know whether that difference is significant, because descriptive statistics will not tell you whether a difference is significant or not. It will only tell you whether there is a difference. So from what we have here, there is a difference in their mean score. All right, 11 tests, we have shown that before. We met that condition because p-value of 0.334 is greater than 0.05. Now we have the main results, which is the analysis of variance results. We have the sum of squared, 3486, though you don't need to report all this, okay? Divide by 2, we give you that mean squared. Then divide mean square 1743 divided by 175.06. It will give you that F value, okay? But our interest is on the P value, which is 0.003. And the P value is less than the level of significance. Therefore, we reject our null hypothesis, okay? The null hypothesis is rejected. Then we go to the explanation of that significant difference. Nobody asked me of the meaning of LSD before. Okay, you know it before, that it's least significant difference. Okay. So, now, the difference between the scores of students in maths department and biology department is minus 36. And that difference is significant at 0.05 level. Have you seen it? We have a star. There's a star attached to that result. Okay? Then when you go down, you see the meaning of the star. The meaning of the star is that is significant at 0.05. Now, take mass and compare mass with agric. The difference there is what? Minus 9.4. But this difference is not significant. So if we are using mass as our control now, okay, it means the biology student did not, is it biology that didn't, no. Let's take the one with the highest score as the control. Which one has the highest score? Biology, So let's take biology, let's compare, let's take it from here. Biology and mass. Now, let's interpret that biology against others. So the difference between biology and mathematics is 36. Okay? And that difference is significant. While the difference between biology and agric students is 26.6. And is it also significant? No, it is. You can see there's a star there. It's significant at 0.05. All right, that means the two other departments did not actually perform very well. Since the difference between their performance and the control is what? Is significant. Do you get it? That is the importance of the multiple comparison tests. It will now give you the exact difference between the control and the other group that you have. Yes. They are. But it's just that the star is helping us. Before we even look at the p-value, the star has already told us what we need to, the reason for checking the p-value, star has given us already. So it's important. You also talk about the p-value. That's, just because we have something that is helping us, that's why we, as if we are ignoring the p-value. It's very important. In fact, I think I mentioned it. I said the p-value for that of agric is 0.008, while that of mathematics is 0.001. Okay, so they are both less than 0.05. Okay, and lastly, let's look at the mean plot. Just a graphical representation of the mean. So the highest mean is agric. Can you see it? Biology, sorry. Biology has the highest, then followed by agric, okay, and mathematics has the lowest. So what we have in that descriptive table for mean is what has been presented here in this means plot. All right, so that is analysis of variance. We still need to take one more example, but not today. We'll leave it till tomorrow. Because I can see my senior colleagues are already getting tired, if not tired already. But I want to give us a take-home assignment. I want to give us a take-home assignment. You don't understand what we did. Do we take it again? The assignment I want to give, or this one? Which one? The one I'm about to give. Now, let me. Okay, that's going to be difficult. Okay, let's take care of that before. Where? Okay, I started from here. Do you understand that of descriptive? We said that the mean for mass is 44, that of biology is 80, and agric is 53.6. Therefore, biology students had the best performance, while mathematics, since their own mean score is the least, had the least performance. Then we also said that there is difference in what? In their mean performance, because the test is all about what? Difference in mean. So now we can say that there is difference in the mean, but we cannot use the word significant here yet. You can just say that there is difference in mean, and then you stop. Is purely what? A descriptive test for now. All right, that's what we said about that table. So in case you are reporting, the only thing you need, the only results you report here are the sample sizes and the mean. All the other results, we don't need it here. We report only the sample sizes. We have the same sample sizes for the three departments, and then you report the mean. Then you also go to the test of homogeneity or variance. It's a test to check whether the variance in the three departments, whether they are equal or approximately equal. And is a condition for us to use analysis of variance. In fact, for us to also use what? What's the second condition? For us to use, for us to pick our multiple comparison. You reminded me before, you have forgotten. Yes, so it's a condition for us to pick any of the first 14, okay, or the last 4. So if we don't meet this condition, you cannot pick any of the first 14. And those ones are the ones we even know. I hardly hear all those names, those other 4, okay? So people are eager to use any of those 14, but it has a condition. And that condition, your p-value here must be what? Greater than level of significance. that condition. Then you go to your analysis of variance. And what I said there is just go straight to your p-value. Forget about the sum of square. Those of you that are not in statistics, you don't need to start explaining how you got the between group, within group. No, it's not for you. Go straight to your p-value. P-value is less than what? Your level of significance. That's all. And then you conclude that you are rejecting your null hypothesis. When you reject, it means you are accepting your alternative. And then you go to your post hoc tests. Post hoc tests, is a further test after you have rejected your null hypothesis. Now it will give you the actual difference between the groups that you have. And I said, let's use biology as a control because it has the highest performance. So we compared biology with the two other departments. When we compared biology, the scores of biology and that of mathematics, we discovered that the difference there is what? 36. Okay? And is that difference a significant one? Yes, because the p-value is 0.001. Is that okay? The same thing with biology. The difference between, with agric. The difference between biology and agric is 26.6. And that difference is also significant because the p-value there is 0.008, which is less than 0.05. All right. I hope I can stop here now. Thank you very much for your cooperation. And, I was willing to teach and you were willing to learn. Thank you for that. Tomorrow,